Hi, today we are going to do a solution video of the International A-Level Pure Mathematics P4 that took place in January 2021. Let's get started. Here is the first problem. Find the first four terms in ascending powers of x of the binomial expansion of this term, giving each coefficient in its simplest form. So here is the formula for the first four terms of the binomial expansion. And according to the formula, we have to make our term to be in this form, the form of 1 plus x to the power of n. And you can see this one, the first term, our first term is still not 1, so we have to change it to be 1 by factorizing it. But the factorization has to be inside these brackets. We factorize 1/4 out so that the first term can be 1. 1 minus 20x, and then to the power of 1/2. Like the whole thing has the power of 1/2. You can see that this term multiplied this term inside this bracket. So then we can expand the power of 1/2 into each term here. So it will be 1/4 to the power of 1/2 times 1 minus 20x to the power of 1/2. And we simplify this term, it will be 1/2 times 1 minus, which we can change to plus. According to the formula here, it has to be 1 plus something to the power of n. So we put negative with 20 like this and to the power of 1/2. Now you can see that this term and this term are exactly the same, like the same pattern. We have 1 and 1 here. And the second term, which is x, we've got this one for the second term. And here is n. N is 1/2. So then we can expand it. We put 1/2 here, and then according to the formula, the first term has to be 1. So we'll put 1 here. And then plus n. Well, n in this case is 1/2. So we put 1/2 here, and times x, which is the second term, here, times minus 20x plus n times n minus 1, it's going to be 1/2 times 1/2 minus 1 divided by 2 factorial, and then minus 20x, all of them squared, plus 1/2 times 1/2 minus 1 times 1/2 minus 2 divided by 3 factorial times minus 20x, and all of them is cubed. We close the square bracket. We still put 1/2 here. Simplify all the terms inside the square brackets. So this one is the same. This one will be 10x. The third term will be minus 50x squared. And then the last term will be minus 500x cubed. Expand 1/2 into each term inside the brackets. So the first term will be 1/2 minus 5x minus 25x squared and minus 250x cubed. That's the answer. Here's the next part. By substituting x equals to 1 over 100 into the answer for part A, find an approximation for square root 5 and give your answer in the form a over b, where a and b are integers to be found. So here's what we've got from part A, and we have to approximate square root 5. That means we better change this one to a square root of 1/4 minus 5x. So the square root of 1/4 minus 5x can be approximated by 1/2 minus 5x minus 25x squared minus 250x cubed. And then we substitute 1 over 100 into x. So this will be minus 5 times 1 over 100, which is 1/2, minus 5 times 1 over 100 minus 25 times 1 over 100 squared minus 250 times 1 over 100 cubed. And then we simplify both sides. For the left-hand side, we can simplify it to 1 over 5, and on the right-hand side, it will be 1789 divided by 4,000. And then we have to rearrange the term on the left-hand side to be something in terms of square root 5. The first term is 1 over 5. So here we have 1 over 5. We can multiply 5 over 5 here to make it 2 square root of 5 over 25. And this one will be square root 5 over 5. So that means square root 5 over 5 is this term. And if we want to approximate for the square root of 5, we can just move the denominator to multiply this term times 5, and it will be 1,789 divided by 800. In problem B, we have this parallelogram ABCD. The vectors AB and BC are given, and we have to find the size of angle ABC in degrees and answer in 2 decimal places. So if we were to find the angle ABC, we have to find the angle between these vectors BA and BC. To find angle ABC, we have to use this formula cos ABC equals to vector BA dot vector BC divided by magnitude of BA times the magnitude of vector BC. So first we have to find the dot product between BA and BC. So here is BA dot BC. It will be minus 6, 2, and minus 3, because BA equals to minus AB dot 2, 5, and 8, which is negative 6 times 2 plus 2 times 5 plus negative 3 times 8, and the answer will be negative 26. Next, we have to find the magnitude of vector BA. The magnitude of BA is the square root of minus 6 squared plus 2 squared plus negative 3 squared, which is 7. And then we have to find the magnitude of a vector BC. It will be the square root of 2 squared plus 5 squared plus 8 squared. And the answer will be square root 93. And we put all these values into our formula. So this one will be negative 26 divided by 7 square root 93. And to find the angle ABC, we can use our cos of negative 26 over 7 square root 93, which is 112.653, which can be routed to 112.65 degrees for 2 decimal places. Next, we have to find the area of ABCD and give our answer to 1 decimal place. And according to the previous problem, we know that BA equals 7 and BC equals square root 93. And the angle between these two sides is 112.65. So you can divide this parallelogram into 2 parts like this. Now we have 2 triangles. They are 2 identical triangles. So for this triangle, we can just use 1/2 AB sine C. But since we have 2 identical triangles, that's why we can just use AB sine C. So the area will be the magnitude of BA times the magnitude of BC times sine 112.65 degrees, which is 7 times square root 93 times sine 112.65, which is 62.3 square units.